All right. So the lesson today is again on graphing sine, cosine, tangent, but this time we have more transformations than the amplitude in the period. So this time we're also going to include that the graph might be shifted up or down or left or right. So we're going to have transformations today. If you look on the left column, when you see inside the function with parentheses, adding or subtracting, inside means it's going to go horizontal. So when I look at this equation, that h inside represents a horizontal shift. The k on the outside represents a vertical shift, up or down. So the k does what it says. If it's adding k, it's going up. If it's subtracting k, it's going down. The h goes in the opposite direction. So positive h means left, and subtract h means right. So inside, it goes in the opposite direction. Outside, it does what it says. So if I look at number 1, can you describe the transformation of this trig? What does the plus 2 do? What kind of shift? It is a vertical shift in what direction? How about number 2? What do you see? What does the subtract 1 do? Again, it's a vertical shift, but this time what direction is it going? Look at number 3. What kind of transformation is that? Vertical or horizontal? And in what direction? Left. How many? Pi over 2. Here, again, what type of shift is it? Horizontal. And what direction is it going? And how many? Shifting a graph vertically will create a new horizontal axis called the midline. That means the middle of our graph has been shifted up or down. So when we're talking about a wave in the middle, if we go up or down, the middle of our wave then has shifted up or down. This reference line to which a graph oscillates. Have you heard that word before? If something oscillates, it goes up and then down, or left and right. That's what the word oscillate means. The equation of the midline is y equals k.
So what does it say right there?
Which one? Midline?
Midline.
M-I-D, like middle, but midline. And our new midline is y equals k, whatever k is. So, in our last lesson, our middle was always at 0, yes? And if we go, where's the mid now if you go plus 4 at the end? Now the middle's not at the y value 0, but at the y value 4 when we graph. So, number 5 and 6, can you graph with a vertical shift? And I know you can. So, number 5, let's start the analysis and graph it. Step 1, what is the amplitude of this wave? 3 over 2 or 1.5. What's the period of this wave? Is there anything inside the function? And if it's inside, you would see parentheses. So do you see parentheses? It's not inside, so nothing has changed, so the period is 2 pi. Phase shift. When we do a horizontal shift, another word for that is called a phase shift. So you hear the word phase, what it means is horizontal. Is there any shifting left or right here? That would be inside the parentheses. And the answer is no. Is there a vertical shift? Yes. What direction? Which means now my midline is at what line? Y equals 3. Sine starts in the middle. What number is our middle now? So can you find the middle, and it's now at what number? That is not the top of the wave. That is the middle of the wave. What is my period? Can you find 2 pi? And the same thing. That's the middle of the wave. Continue the pattern. What's in between those? And again, that's the middle of the wave. Sine starts with middle, middle, middle. The first two midpoints, what's in between? How far up do I go from the middle? 1.5. So from here, can you go 1.5? And why am I going to the top first? Because sine is positive. And then in the next two, in between, I'm going to count down 1.5, and you've translated the wave up 3. Can you follow that pattern to the left? So the scale of the graph is what we've been doing. 1, 2, 3 over 4, and so on, right? We start, and our 2 pi begins and ends the cycle. And then in the middle, and then it goes to the top and the bottom. So we're going to continue that pattern to the left. So I'm going to count 1, 2 to the left. And then I'm going to go 1.5 down. I'm going to count 1, 2 again to the left. And that's in the middle. I'm going to count again 1, 2 to the left. 1.5 up. 1, 2 to the left. And again it's in the middle. And then when I connect it, it's going to be a curvy wave that goes up and then down, arrows at the ends. And you just graphed a sine function. Can you see the whole wave has been pushed up 4 or 3? Number 6. Does tangent have an amplitude? No. Does tangent have a period? Yes. And the period would be pi. Is there anything multiplying in front or dividing inside that would change it? And the answer is no. Adding or subtracting does not change the length of the period. Phase shift. Is there something inside adding or subtracting? Yes. And we have to go in the opposite direction. So what's the phase shift? It's going left pi over 2. I'm going to circle this because this is really important, because when we start graphing, we no longer start on the y-axis. We now have to start, and it's been shifted to the left where we start. We'll get there. Is there anything adding or subtracting at the end? So the midline has stayed the same. All right. Tangent starts with a point of inflection. Can you find where negative pi over 2 is? At negative pi over 2, we're going to start right there. That's where our graph starts, because it's been shifted to the left. Negative pi over 2. We're starting there. Now, the period is pi. This is going to be a little bit more challenging because we're not starting at 0. What is negative pi over 2 plus pi? Negative pi over 2. And if you add pi, where does our period end? Or you can count boxes. How many squares make up 1 pi? 4. So from the point I just did, count 1, 2, 3, 4, and that ends one cycle. What goes in the middle between those 2 points of inflections? An asymptote. And we're going to continue that pattern. And again, in between will be asymptotes. Next, remember where I started. Do you remember where I started? Go right back to where you started. Tangent goes up to the right unless it's negative. What number don't you see that's in front of tangent? So in between, can you find positive 1? And we're going to curve through that up to the right. In between, can you find negative 1? And we're going to frown down to the left. So find positive 1 up to the right, negative 1 down to the left. Positive 1 up to the right, negative 1 down to the left. And follow that pattern. All right, when you're ready, turn the page. Oh boy, there's a lot of stuff happening here. You ready? So, I love it that you know when there's something happening that you pay attention more, not less. Can you tell me the amplitude of this wave? Do you know where to look? What number is the amplitude? Excellent. The period would start with 2 pi. Is there anything multiplying or dividing inside? And yes, and the number is 2/3. When it's inside, you have to undo it. So how do I undo a fraction? I like that, Tommy. So what is this? 2's divide out. What do you end up with? 3 pi. Beautiful. Phase shift. Is there anything adding or subtracting inside? And you do the opposite direction. And I'm going to circle it. And you know why that's important? Positive pi? Because that's where my graph is going to start when I start. Vertical. Anything adding or subtracting at the end? So everything's going to be pushed up 1. All right, we're ready. Do you see what I circled? Where are we going to start this graph? At pi. What does cosine start with? The middle of the wave? The top of the wave. Now, normally, what would the top be? But what are we going to do at the top of the wave? Instead of 4, we're pushing it up 1. So now where's the top of our wave? So at pi, can you find where 5 is? 5 is the top of our wave. Now, what's our period? 3 pi. If you went pi plus 3 pi, the answer would be 4 pi, but that's way off my graph. If I counted the squares, how many squares make up 3 pi if I count it across? 1 pi is 4 squares, yes? So 3 pi must be 12 squares. So half of 12 is, so 1, 2, 3, 4, 5, 6 is just off my graph, but that would be the bottom of my wave at 6. I'm actually still going to put it on there. Now, the bottom would normally be at -4, but we're going to add 1 that's been pushed up. So now the bottom of the wave is at -3. So I'm just going to go a little bit off my graph. I'm going to go a little bit off my graph and know the bottom is at -3. In between those 2 points is going to be the middle of my wave. And at what number is the middle of my wave? So I'm going to count 3 across and right here. That's the middle of my wave. I know my scale of my pattern. Every 3 squares is going to be the top, the middle, or the bottom. So from here I'm going to count 1, 2, 3, and that's going to be the middle. Again, I'm going to count 1, 2, 3, and that's going to be the bottom. I'm going to count 1, 2, 3, that's going to be the middle, and I'm going to count 1, 2, 3, and that's going to be the top. So there's my scale, counting 1, 2, 3, middle, 1, 2, 3, bottom. Are you aware that 5 and -3 are your top and your bottom? Are you aware that 1 is the middle? And then connect it with a curve. All right, here's our last one, number 8. I'll put the other 3 on a video as well so that you can watch them too. And we'll practice tomorrow. Here we go. Number 8, our last one for today. Tangent has no amplitude. The period for tangent is pi, but do you see the times 2? To inverse times 2, we're going to divide by 2. So this 2 inside changes the period to pi over 2. Look inside the parentheses. Where's the phase shift? And I'm going to circle it. It's at -pi/4. The vertical shift is -3. So our midline now is down 3. So find -pi/4. Go down to -3. And that's where we're starting. That's where the point of inflection is. -3 and -pi/4. Our period is pi/2. That's 2 boxes only. So go 2 to the right, and again, what do we have? A point of inflection. And in between there is going to be an asymptote. And now we have a simple pattern. We're going to go over and over and over and over and over again. So we're going to follow that pattern all the way across. Notice the point of inflection doesn't oscillate. The point of inflection stays the same level all the way across. Now, tangent goes up to the right. What number don't you see in front of tangent? So in between, we're going to go up 1 and curve it. In between, we're going to go down 1 and curve it. Tell me, Jose. We good?
Yeah, we good.
All right. Did you finish it?
Oh, no, I'm watching.
You just got it. So in between, up 1, in between, down 1. Over and over and over and over and over again. A periodic function means it repeats over and over and over and over. All right, so there's the beginning of your lesson. Understanding transformations and trig functions. Mr. G Math, over and out.